Welcome to Tech Talk Friday, and it's Friday, and every Friday we talk tech, right? Today we're going to talk a little bit about NVIDIA, and we're gonna dive into it's crazy, right? The price of the NVIDIA stock is just out of control, right? 2 trillion plus company. I know when it was 50 billion, people were saying, "Oh my goodness, NVIDIA is an expensive stock," and then it's 500 million, valuation, 1 trillion. And now we're down to 2 trillion plus, right? So it's amazing run. So Nvidia is actually founded in 1993, so it's not a new company, not a startup. They started by creating graphic processing units or GPUs, right? And this they did for PCs, right? And these chips excelled at handling complex visual information. So gamers, graphic designers, they love these GPUs, right? Now over time, NVIDIA recognized the power of GPUs for tasks beyond graphics, right? So they discovered that GPUs can actually do calculations in parallel, and this created a new field called deep learning, right? So we I want to take some time to basically understand and explain a little bit about GPUs. Then we can talk a little bit more about NVIDIA, and then we'll dive deep into what we call the NVIDIA Deep Learning Institute, right? So we'll take our time and go through that. So my understanding of GPUs, right? So graphics processing units are these specialized electronic circuits. They are designed to accelerate the processing of images and videos. So these are unlike CPUs. Now, what CPUs? Central processing units, right? These are designed to handle a wide range of tasks quickly. GPUs actually optimized for tasks that require large amount of data to be processed simultaneously. So things that GPUs are good at, graphics rendering, right? So that's kind of the primary function of GPUs, to render graphics. And this enables like intricate or creation of intricate images and animation in real time. And this is crucial for video games, professional graphics applications as well. There's also this, so graphics rendering is one, parallel processing, right? So GPUs are designed with thousands of smaller cores that actually handle multiple tasks simultaneously. So they're very good, making it's this whole thing called parallel processing, right? So this capability is, if you look at it, it's leveraged in fields such as scientific computing, data analysis, and AI, right? And that's where the third part, right? So artificial intelligence and machine learning. So graphics rendering, parallel processing, AI or artificial intelligence and machine learning is where GPUs become integral, right? Because why? Machine learning, because of the ability to process large data sets efficiently. So they accelerate the training of complex neural networks, reducing the time required to develop and deploy AI models. So GPUs have evolved, right? So again, 1993, I think, is where NVIDIA sort of started, right? So from that time, as they started to evolve, right, April 5th, 1993, Jensen Huang, Chris Mikulski, and Curtis Prem, right, the three of them, they sort of they had a background in electrical engineering, computer science. They had this vision of enhancing computer graphics capability, right? So GPUs evolved. Early GPUs were primarily on 2D graphics rendering. Today, as they have transformed, and as the company NVIDIA has transformed, their powerful processors capable of handling complex 3D graphics, high performance computing tasks, and AI workloads, right? So let's talk a little bit about NVIDIA. So April 5th, 1993, these three guys started NVIDIA. And their initial focus was really, in the early years, was developing graphics accelerators. So their first success, right, essentially was this Riva 128 that was released in 1997. So Riva 128 was released in 1997, and this graphic card provided significant performance improvement over existing solution, and NVIDIA became a serious player in the industry, right? Then was the GeForce series. So 99, they introduced the GeForce, GeForce or GeForce or whatever, GeForce 256, right? Which is marketed as the world's first GPU, right? So this incorporated a hardware transform and lighting engine, right? And this set a new standard for graphic performance in gaming and professional. Now, the expansion into AI and data centers, this happened as time went on. NVIDIA recognized the potential of GPUs beyond graphics, right? So it expanded its focus to include high performance computing and AI. And this introduced CUDA, Compute Unified Device Architecture, CUDA. And this was in 2006. This enabled developers to harness GPUs for general purpose computing tasks, right? Paving the way for AI and deep learning. Now, acquisitions they made a couple of acquisitions and strategic, most notably the acquisition of Mellanox technology in 2019. They enabled them to expand or bolster NVIDIA's capabilities in data center and networking solution, right? So NVIDIA's had profound in the gaming industry, that's for sure. Professional visualization, film, animation, design, definitely relied on NVIDIA's GPUs and now artificial intelligence. And that's why NVIDIA stock is going gangbusters. Now, the other piece, the NVIDIA revolution really is about deep learning. So what's deep learning? Now, deep learning is a type of artificial intelligence. So let's zoom in into this whole space of deep learning, and talk a little bit about that, and then we can understand why NVIDIA stock is 2 trillion, and people said, "Hey, that's the right price. It's valued correctly, right? At this price." So deep learning is this type of artificial intelligence inspired by the human brain, right? So it uses artificial neural networks mimicking the brain structure to learn and improve from vast amounts of data. Now, this allows computers to perform tasks like image recognition, speech recognition, and even creative writing at an incredible level. Think of it this way, right? Imagine a computer learning to identify cats in a picture. Now, a normal CPU might take hours, but with an NVIDIA GPU, right, especially with tensor cores, you could do it in minutes. And this efficiency is how it's revolutionized numerous fields, right? Take a look. The deep learning, right, is a subset of machine learning, with the difference that deep learning algorithms can automatically learn representation from data such as images, videos, text, without introducing human domain knowledge. The word deep, right, in deep learning represents the many layers of algorithms or neural networks that are used to recognize patterns in data. So deep learning's high flexible architectures can learn directly from raw data, similar to the way the human brain operates, and can increase their the predictive accuracy when provided with more data, right? So let's talk a little bit about how deep learning works, and I want to show a little graphic here, um, on how deep learning works, right? So deep learning, and I'll get my producer to kind of put that layer on, right, or how DLI works, right? So you can see this out here, right? So deep learning uses this multi-layered artificial neural networks, or ANNs, right, which are networks composed of several hidden layers of nodes between the input and output. So an artificial neural network transforms input input data by applying a non-linear function to weighted sum of the input. So the transformation is known as a neural layer, and the function is referred to as a neural unit, right? So I'll show you the kind of another sort of you look at data sets, and how we have trained these neural networks, and then we end up with what you see over there, right? So the intermediate outputs of one layer called features are used as an input into the next layer. The neural network actually learns multiple layers of non-linear function like edges and shapes through repeated transformation, which it then combines in a final layer to create a prediction of more complex objects. Let's with back prognostication inside of a process called gradient descent, the errors are sent back through the network again, and the weights are adjusted, improving the model. So the neural net actually learns by varying the weights or parameters of a network so as to minimize the difference between prediction of a neural net and the desired value. So this process is repeated thousands of times, adjusting the model's weight in response and to the error it produces until the error can't be reduced anymore. So this is where artificial neural network learns from the data, and this phase is actually called training. So when they say, "Oh, we're training the LLM," or "We're training, my AI," right? That's what it means, right? The data sets go into these NVIDIA digits, and then they're trained neural networks, and then ultimately they get to this point of what it needs, right? So that's kind of, in a nutshell, the sort of overriding piece, and ultimately, this is kind of how the DLIs sort of work, or deep learning works, right? So with that, let's talk about GPUs, right, and where NVIDIA comes in, right? So architecturally, the CPU is composed of just a few cores, and we got to understand the difference between a CPU and a GPU, right? And I think this is where it becomes relatively interesting, right? So CPU is comprised of just a few cores with a lot of cache memory that can handle a few software threads at a time. Now, in contrast, a GPU is comprised of hundreds of cores that can handle thousands of threads simultaneously. So state-of-the-art deep learning neural networks can have millions to well over 1 billion parameters to adjust using what they call back propagation, right? So they also require a large amount of data training to achieve high accuracy, meaning hundreds of thousands to millions of input samples will have to go to be run through both a forward and backward pass, right? Because neural nets are created from large numbers of identical neurons. They are highly parallel by nature. So this parallelism maps naturally to GPUs, providing a significant computing speed up over CPUs, CPU-only training, and making them the platform of choice for large or for training large complex neural network-based systems. And the parallel nature of inference operation also lends themselves well for execution on GPUs, right? So think about deep learning, and I think maybe now what we should do is talk a little bit about deep learning and some of the use cases for deep learning. And one thing I want to talk a little bit about at the end is NVIDIA's Deep Learning Institute, right? So NVIDIA is actually launching a deep learning institute over here in Malaysia, and one of the things that I think is very interesting with NVIDIA's Deep Learning Institute, and you can check it out. You go to learn.nvidia.com. You can check out NVIDIA's Deep Learning Institute over here. And what you will see, interestingly, is how NVIDIA's and I'll show you right here. You can have a look at it. How NVIDIA's Deep Learning Institute is essentially enabling everybody to become deep learning experts, right? And NVIDIA is about to launch this deep learning institute here in Malaysia in partnership with Leadernomics, and I think we'll see folks like PSDC and many others leverage this deep learning institute, and this will enable everybody to be able to learn and be able to use deep learning. So let's talk a little bit about some of the sort of use case. Deep learning is commonly used across apps in computer vision, conversational AI, and recommendation systems. So computer vision apps use deep learning to gain knowledge from digital images and videos. So they kind of look at digital images, videos. They sort of learn. Conversational AI apps help computers understand and communicate through natural language. And you've seen that, right? ChatGPT and others. And recommendation systems uses images, language, and the user's interest to offer meaningful and relevant search results. So you see a lot of the search programs, or even when you go in and look for something, in some of these e-commerce apps. There's a lot of what we call a recommendation system that's being used. So that's deep learning, right? So deep learning is enabling self-driving cars, personal assistant or smart personal assistant, smarter web services, and you think about applications of deep learning, so fraud detection, supply chain modernization, and companies all over the world are using deep learning. And there's different variations of deep learning algorithms. So there's ANNs, where information is only fed forward from one layer to the next. And these are called feed-forward artificial neural networks, right? So then there's multi-layer or MLPs, right? Perceptrons. They're a type of a feed-forward ANN consisting of at least 3 layers of nodes. So an input layer, a hidden layer, and an output layer. So MLPs are good at classification, prediction problems using label inputs, and they're flexible networks that can be applied to a variety of scenarios. So that's ANNs, right? Then there's also convolutional neural networks. These are the image crunchers to identify objects. So CNN image recognition. So it's called CNN, ANN, CNN. And the last one is recurrent neural networks, mathematical engines to parse language patterns and sequence data. So those are some and that's called RNN, right? So when you hear terms like ANN, CNN, and RNN, that's essentially what it is, right? So ANNs, CNNs, convolutional, and recurrent neural networks are RNNs, right? So these are typically, let's talk about deep learning impact. So we talked about self-driving cars, right? That's using powerful GPUs, medical research, scientific discoveries, entertainment, right? So a lot of entertainment is using that. And in the future, Omniverse, gaming, Metaverse, all these things will be driven by what we call deep learning, right? And ultimately, once we understand that, we understand the need for a deep learning institute. So I go back to the NVIDIA Deep Learning Institute that I was showcasing to you just now. I think it's very important. As you kind of look at this NVIDIA Deep Learning Institute, you're able to learn what deep learning is, but more importantly, you're able to leverage some of this learning to be able to see technology can only be deployed when there's talent, and when there's no talent to be able to deploy, it's not going to happen. And this is where the NVIDIA Deep Learning Institute becomes very, very critical. And I'm so happy to announce that in the next couple of months you will see this deep learning institute being established, the products, the programs, and it's going to be available to most folks here in Southeast Asia. through this partnership in terms of enabling the Deep Learning Institute to be able to thrive in Malaysia, to be able to see more and more talent forthcome. So that's the NVIDIA Deep Learning Institute that we talked about. I think a couple of other things we'll quickly cover in this tech talk, and obviously NVIDIA stock price. Everyone's asking, hey, it's it's valued at 2 trillion plus. Is it worth buying? Again, I hard to answer, but the way the industry is moving, it's going to be a bigger and bigger industry, right? Everybody will require GPUs, and a lot of companies are starting to develop GPUs, but it's going to take some time. Again, want to share, as and just buy NVIDIA. The stock is priced like I remember 50 billion people saying it's crazy, and now it's at 2 trillion and people say just buy NVIDIA, right? So you never quite understand how that works. So again, for those who just joining us, we're talking about the power, unveiling the power of NVIDIA. And if you're watching this show across the different channels, feel free to put in your questions and ask them. But I wanna make a call out. This show is brought to you by CyberArmor.Asia. So for those of you who have not heard about CyberArmor, I mean, one of the things I think that's very interesting about this organization is the stealth-based technology that it offers. So while NVIDIA, right, while we're going to see the industry grow, there's going to be more fraud. There's going to be more hacking. There's going to be more a significant amount of folks that are going to be attacked. I mean, there's going to be significant cyber attacks. And I think one of the things to overcome cyber attacks is using technology like what CyberArmor has, which is Shepherd, right? So just to ensure that we honor our sponsors, CyberArmor. Here's a quick little insight on Shepherd, and it is, to me, the most innovative cybersecurity solution out there. It's not a wall, but it's a stealth-based, network-based approach. So here's a quick look at Shepherd. All right, so Sidi, nice to meet you, and I'm assuming Professor Hani is also online. Great to have you guys on the show. So Shepherd is available finally. This super stealth-based opportunity to have a product that is stealth-based that will enable you to have zero hacks or completely reduce the surface area attacks available in Malaysia. And you can reach out, to you can check out cyberarmor.asia, and you can also sort of reach out to Azriel, and I'll figure out how to put his contact information. My producer will put up his contact information for those of you interested in stealth-based solution. Now, another guest that we're gonna have coming up is a guy called Tarif Jafiri. He's gonna be a guest here on our show in the next couple of weeks. And he has an amazing product called Happily. So, for those who haven't checked out Happily, Happily.ai, it's an incredible tool. And I'm super excited because this guy, ex-Google, he's kind of ex and I'll show you a bit. Here's one of his tools, Happily.ai. Supercharge your teams, and you can check it out. The insights it gives, and some of the amazing things that it offers in terms of reducing turnover and enabling you to understand your employees better. So Tarif Jafari is going to be on our show in the next couple of weeks. We also have folks from Google, who's going to be on the show. Tarif actually worked in Google for a number of years, but we also have folks from Google going to be on the show with Dr. Wimi, who's formerly the CEO of IHS Market. She's going to be coming out on the show, and a host of others. So look forward to next few episodes. This is going to be a short one, and that's next week. I think it's where techs get, Tech Talk Friday, where tech gets real, tech that matters, talk that counts. Dr. Wimi Ramasamy, she's CEO of Stravic today, but in the past, she was the CEO of IHS Market. So we have that coming up for you. It's going to be exciting times. And I look forward to having each and every one of you back next Friday on Tech Talk Friday. So with that, it's a wrap for today. Look forward to having you again next Friday, and we'll talk more tech. Hopefully you enjoyed this segment on NVIDIA and understanding why is NVIDIA valued at such an incredible rate, and what the heck are these GPUs. So hopefully this gives you a bit of a grasp of what GPUs are and why NVIDIA is so valued. With that, goodbye for now, and we'll see you next week at Tech Talk Friday with Dr. Wimi coming up. Following week, we have Tarif Jafari, and we have head of the US Red Team is going to be on in a couple of weeks, and many other fantastic guests. So we'll see you next week on Tech Talk Friday. Bye for now.